Hello, I'm John Davidson, and welcome to Intermediate Algebra. This first section, back to this first topic, is one you've all done before, solving linear equations. But I want to take probably a little deeper look at solving equations than you may be accustomed to. Part of my job here is to get across to you some of the deeper aspects of math, why it works, and to build your understanding of mathematics beyond just trying to memorize how to do things. So anyway, let's get started with solving an equation. And here we are. In these videos, I'm going to read everything I write on the board here, just to make sure it's clearly legible as to what you're seeing. So this says to solve 2x minus 7 minus 6x equals 8 plus x minus 25. Okay, now our first step, probably one of the best steps we can take here, is to shrink down both sides. So I'm going to combine terms on each side separately. And here you see that we have 2x and minus 6x, they're like terms. We can combine those. So 2x minus 6x is negative 4x, and then the minus 7 stays where it's at. On the right side, I can combine the numbers. 8 minus 25 is negative 17, and then plus x. So this is typical of all linear equations. You can always shrink it down to no more than 4 terms by simplifying each side separately. All right, now what's our next step? Well, I'm going to, what does it mean to solve? To solve means to get x equals to a number. And so I have to isolate x. And I have x's on both sides. So now this is where we begin the transfer from one side to the other. And I think I'm going to subtract x here. Now, this first step, it doesn't really matter what you do, as long as you do it to both sides. We could add 17 in order to cancel the negative 17. We could add 7 to cancel this negative 7. We could add 4x to both sides. As long as you do it to both sides, you keep the balance, everything is fine. So it's, I think, a matter of taste where you begin at this point. All right, minus 4x minus x is minus 5x. I'll bring down the minus 7, minus 17. And here, these are going to cancel, leaving 0. So x minus x is plus 0. And there's no sense putting a 0 there, so there we have it. Now look how I'm doing this. You're going to find that my work throughout all these videos and in my books, I'm going to be trying to be very organized. And you see I've got the minus x on both sides. You can clearly see that we've kept the balance of the equation. All right, so textbooks tend to put everything on the same line, the same safe space, but I don't think that's a good idea. Because here it's pretty clear that we're subtracting x from both sides. All right, now what would you do next? Well, now there is a best next step here because we have x's down to one term. We need to get the non-x's to the other side. So I'm going to eliminate the minus 7 by adding 7. So I add 7 to both sides. And this gives me minus 5x by itself because the 7's cancel. And let's see, negative 17 plus 7 is negative 10. Okay, one more step. And what do? Minus 5 is multiplying x. I need to get rid of minus 5. The opposite of multiplying is dividing. So I'm going to divide by minus 5, both sides. So again, I'm continuing this very neat process of doing the same thing to both sides of the equation. All right, now these cancel, and leaving x equals 2, and negative 10 over negative 5. Always simplify your fractions, and this comes out to be 2, exactly 2. So, all right, there's our answer. Now, one thing I'd like to point out is, one of the first things you learned about algebra was the order of operations. Remember, the order of operations says you're supposed to do you're supposed to simplify things in parentheses first, and then you're supposed to do the exponents, and then multiply and divide, and then add and subtract. Just just an observation here. We sort of did this backwards. That I added and subtracted first to simplify, and then I multiplied or divided to finish the problem. So I did addition and subtraction, multiplication and division. All right, I don't know if that's terribly profound, but it's kind of interesting that the typical process in solving equations is sort of the reverse of the order of operations. So for what it's worth, that's, I think, interesting. Now, there are always exceptions to this, but typically that's what happens. All right, well, we have an answer. Now let's check to see if that's the right answer. Okay. Now, about checking answers this way, how I'm going to do it. I know a lot of students, probably most students, really resist doing this. And I got to tell you that if you take the time to check your answers the way I'm going to show you, you're going to do great. You really are. And because when you check your work whenever you can, you really build a much deeper, better understanding. And you just get better at the accuracy also. So, all right. So how do I know this is an answer? This is the correct answer if this is what satisfies the equation. So what does it mean to satisfy the equation? It means that it balances the equation when I replace x with my answer of 2. So I'm going to check it here and replace x with 2. 2 times 2 minus 7 minus 6 times 2 equals 8 plus 2 minus 25. And this won't take much. Let's see, there's 4. 2 times 2 is 4 minus 7 minus 12 equals 8 plus 2 is 10. 10 minus 25. And here I've got 4 minus 19. 4 minus 19 is negative 15, and 10 minus 25 is also negative 15. So it checks. That's the correct answer. All right. Well, all equations can be checked. It later on in math you'll find that there's some times where it's not that productive to try to check it this way. There are other ways to check your work, but for now this works great. All right, now I got one more question to throw at you here. How do we know that's the only answer? Is it true that all math equations have a single answer? Well, you'll eventually see that's not true. There are equations with 2 answers, 3 answers, infinitely many answers, depending on the situation. So, but linear equations have one answer. Now, where does that word? What's that word linear have to do with this? Linear, of course, comes from the root word line. And you can recognize in algebra a linear equation when the exponents of the variable is always 1. And there's nothing like x squared or x cubed. There are not variables multiplying each other like x times y. That doesn't happen. You don't have a variable in a denominator, like 1 divided by x. You don't have that. That's you don't have anything like square roots or logarithms or sine or cosine. So this is a real typical linear equation. And it turns out you can show that linear equations really do represent lines. Now one of the miracles of algebra that was uncovered around the 1600s, about 1642, by René Descartes, was that algebra has a geometric side to it, just as geometry also has an algebraic side. And Descartes was the one who found a way to blend these together. And so we have a geometry way of looking at this problem. And so this is a little bit extra for you, but I like to show this early in the course, just to impress upon you that there is a geometry behind a lot of what we do in algebra. And as you move up in math, if you take more and more math, you'll find that this link between geometry and algebra really does a great deal to inform you on how things work in algebra. All right, so I'll quit rambling here, and let me Let me just quickly show you what I'm talking about. And then this will hopefully persuade you that there's only one answer to this equation. All right, so if we combine terms here, we get, like we did before, we had minus 4x minus 7. And over here I've got x minus 17. So that's simplifying both sides. All right, if I look at this left side as equation y equals minus 4x minus 7, and the right side as equation y equals x minus 17. You may recall from your first algebra course that these are equations of lines that you can graph. And what happens when you graph these, and I'm just going to have to really guesstimate it here. I'm not going to try to make a really super graph, but let's see. This graph would be, let's see, it's going to go like this. Well, that's minus 17, this is 17. And just take my word for it right now that this is what's happening. This graph comes down about like so. So really, the left side of this equation is represented by this steeply declining graph. The right side of the equation is represented by this diagonal graph here. And guess what? They meet down here at, where would they meet? I know what I'm doing. I think it's at 2 comma negative 15. But the main point is that if you come up here, that's 2 on the x-axis. And so here's a little miracle that was behind the scenes of solving this equation. It looks like a rather boring type of equation, but what happened was that we managed to find where two lines intersected on a graph, and the x value of their intersection was 2. X equals to 2, which was the solution to this problem. So I always thought that perspective is pretty interesting. I hope you found it neat also. But anyway, why does it have one answer then? Okay, well, straight lines can only intersect in one place, can't they? As long as they're not parallel or stacked on top of each other. If they run in different directions, they can only cross in one place. So we've just demonstrated that, in a sense, that linear equations can only have one answer at most, and or at least one non-trivial answer. I'll elaborate on that in a minute. But anyway, by and large, they're all like this. They have one answer. So, okay, well, I have 2 other quick examples to show you to round out this particular topic. Okay, here's a really interesting example, at least to me it is. I didn't want to leave the wrong impression. Linear equations can also have no solutions. And this is the simplest equation I can think of that has no answer to it. Solve x equals x plus 1. All right, now there's about one thing to try here that makes sense, and that's to subtract x from both sides. And when we do so, what happens? X's cancel on the left, 0. On the right, x's cancel, leaving 1. 0 equals 1. Now what? Well, that's certainly a problem. So, but it's impossible, and so I would write no solution. So, you need a conclusion. Don't just don't leave your reader or the person grading your papers just hanging with 0 equals 1. Let us know what you decide that means, and that means that there is no answer to that equation. So, now how can that be? How can there be an equation with no answer to it? And well, it's a very simple explanation by looking at the geometry of it. And so if we looked at the left side as the line y equals to x, and the right side as the line y equals x plus 1, then when you graph it, and again I realize that we're not going to do graphing until the next chapter, but it's something I think probably most of you have seen somewhere in the past. So just take my word for the graphing for right now. Y equals x is this line here going through the origin, and y equals x plus 1 is this line going through y-intercept at 1. Okay, well, that's supposed to be straight. It's a little wobbly. But the idea is that they're parallel. They're parallel. So if you learned about slope in your previous algebra, each of these lines has the same slope of 1. That means they're going in the same direction. They're parallel. And what do we know about parallel lines? They do not intersect. They do not intersect. And so without that intersection, there's no solution to the algebra problem. In other words, the algebra confirms that it's impossible to intersect these lines, and vice versa. So there, I think it's, the geometry is telling us something about this oddity, this strange situation. All right, now, we'll run into a couple of these along the way in this course, but they're pretty rare. Generally, these problems are not too interesting, but, once you see the first one. But it's worth a mention. Okay, I have a third type of equation to show you here. So let me erase the board and put that up. Okay, one more equation to look at in this video. Solve 2x plus 4 equals 5x plus 9 minus 3x minus 5. And what's going to make this one different? Well, we'll just see. Let's see what happens. When you, we can't simplify the left side, but the right side we can simplify. So we can combine 5x and minus 3x. That gives us 2x. And 9 minus 5 is 4, plus 4. And so, look at this. We have 2x plus 4 equals 2x plus 4. Of course it does. And now what do? If you were to subtract 2x from both sides, subtract 4 from both sides, you would come down to something like this, which is always true. So this type of equation is called an identity. And one thing about an identity is that it's true for every possible input value for x. Now, there's a few types of equations where there may be a couple of exceptions where you can't plug numbers in. For example, you can't divide by 0. But by and large, an identity is generally works for everything. All numbers. All numbers will fit into it. So, in other words, no matter what x you could think of to put in here, everything's going to balance out. So here we have the opposite extreme from the last problem. The last problem had no solution to it, and this one has actually infinitely many solutions. And why is that true? Because they're both the same lines. And so one line stacked on another, these lines intersect everywhere. So anyway, so let's recap. Linear equations almost always have one answer. Once in a while you'll run into an oddball that has no answers. It's impossible. And then once in a great while you'll run into one with, like this, an identity, which is true for every value of x. So my conclusion here is identity. And there you have it. So now, to be practical, you're going to focus on the first type, solving equations with a single answer. And in this section, because this is sort of a review section to get you back in the swing of things, solving equations. And okay, well, I'm going to erase this and do one little quick recap about solving equations. Okay, when it comes to solving equations, you'll find that the process of solving equations is a simplifying process where you simplify both sides separately, and then you start combining across equal sign, and this combining across equal sign process is an undoing process. We add or subtract numbers in order to cancel things. We multiply or divide in order to cancel numbers. So the process of solving is sort of an unraveling, an undoing process. So anyway, that's about where it is, and you can check every one of them. When you get that single answer, of course, those types of equations, you can always plug that number in and check it to make sure it's correct. All right, well, we're going to move on to some more complicated equations here next.